question 155. Are the following pairs of expressions equivalent? Explain how you know using at least two different methods. Okay, so let's just simplify A. X squared minus 1 over x squared plus 1. So if I can factor both of these sides and see if I can cancel anything out, I know that x squared minus 1 is the difference between squares, which makes it really easy to factor. I take the square root of x squared, which is just x, and the square root of 1, which is just 1, and 1 is a plus, and 1 is a minus. Okay. Over. But you can see that the denominator cannot be factored. So that's going to remain x squared plus 1. And now we can tell, since we can't do anything else here, we can tell that this is not equal to negative 1. I will say, and we don't have time to do it here, but any of the second ways to check this out, if you just put it into the calculator, I'm just going to show you where to put it in, that you can double check yourselves. And I'll let you do that on your own. But if you go ahead and put those two equations into the y equals, you will be able to have that be the second way you check. Okay, moving on to the next one. Are 3x plus 2 over x minus 1 and 3 plus 5 over x1, in fact, equivalent to each other? So I can combine these two terms as long as I have a common denominator, the denominator of x minus 1. So double check yourselves and make sure you have all these steps written down so you can study for the test. If I want to make 3 have a denominator of x minus 1, I need to multiply both the numerator and the denominator by x minus 1. And I'm adding 5 already has a denominator of x minus 1. My numerator then becomes 3x minus 3 plus 5 over x minus 1, which does in fact simplify down to 3x plus 2 over x minus 1. So I have proved that those two are the same. If you want to do it a second way, please use your calculator. All right, moving on. We are composing functions. Let g of x equal x squared minus 2x. Find g of a. So you guys can tell, up here we have g of x, here we have x, and here we have x. So if we have g of a instead of an x, we are just going to have an a. So g of a is equal to a squared minus 2a. I'm going to make this a little bit bigger. Okay. Now let's try g of t minus 2. This time, instead of x, I'm going to have t minus 2. So g of t minus 2 is equal to t minus 2 squared minus 2, let me erase this part over here, times t minus 2. Now, it doesn't say to simplify it, so I'm just going to leave it like this. But if you wanted to multiply t minus 2 times t minus 2, since it's a binomial that you're multiplying, you're going to need to use your area square, right? T minus 2 times t minus 2. I'm not going to do that right now, but in the future, if you need to square something that's a binomial or anything larger than a monomial, you're going to need to use your area model. Rewrite each expression below using the properties of exponents. Oh, we probably need to make some posters of this for the test too, just putting that out there. So let's start with, maybe I do need a medium point. The first one is a power to a power. We have 5a to the negative 2 power, all of that squared. What that really means is we have 5a to the negative 2 times 5a to the negative 2. 5 times 5 is 25. A to the negative 2 power times a to the negative 2 power. I just have to add those. I get to the negative 4 power. If I didn't want to rewrite it like this, I could have just said, if you look back over here, 5 squared is 25. And when you take a power to a power, you just multiply those together. If you wanted to write it with only a positive exponent, you could have also written this. This is equivalent to 25 over a to the positive 4th power. Okay, both of those things are correct. B, we still have power to a power. So this time we're just going to do it twice. We have negative 1 times 3 is going to be m to the negative 3. And then n to the negative 6, because negative 2 times 3 is negative 6. We could also rewrite this if you want only positive exponents. It doesn't say you have to, but just in case it shows up this way, we could write this as 1 over m cubed n to the 6. Those two are equivalent to each other. This next one's pretty easy. Anything to the 0 power is just 1, remember? So 2 times 1 is just 2. So what this is actually equal to is 2 times 2x to the negative 1, which is just 4x to the negative 1. Or, if you want to do it only as a positive exponent, 4 over x to the positive 1. Or I guess that would just be 4 over x. All of these are correct. The next one, factor each binomial. I'm going to do one of them kind of in a long way. No, I think you guys are okay. This has 2 x's, this has 1 x's. I think the greatest common factor of 2x squared and 5x is just x. Let me know if you disagree with me, but I think that's correct. So we're going to pull an x out. Parenthesis. So what we're looking for, you guys, is x times what is going to give us 2x squared back. And that's just going to be 2x. Plus, now we're looking at x times what will give us 5x. That's just going to be 5. You can always check yourself by distributing it back. If we distributed this, we get x times 2x, which is 2x squared, plus x times 5 is 5x. As you can see, we got the same thing back, so we know we are correct. All right, next one, factoring. I have a bunch of stuff. I am going to do this long way just since we have the time, and I don't have to repeat it since we're recording it. And what I mean by long way is if I take 3x squared times y to the 5th, I'm going to expand it. That really means 3 times x times 1, 2, 3, 4, 5. Okay? And then, if I take, I'm going to ignore the minus sign right now, but if I take 9xy cubed and I expand that, I get 9 is really 3 times 3 times x times y times y times y. And we're going to figure out what these two have in common. So they each have a 3 at least. They each have an x at least. And there's 3 y's here and 3 y's here. That's what we are going to factor out. So what I'm going to factor out is 3xy cubed, parenthesis, and then what's left over is what's going to stay in. So on this first term here, I have 1x and 2 y's, so I have xy squared. Then subtracting, that comes from the original problem. And what's left over in the second one is just a 3. It's just a 3. Okay? And you can check yourself. I'll let you do that by distributing it back through. All right, back with period 3. We are on 58C. Let me erase all of this. Okay, so the question is, can 17 go into 54? And I think it can. So when I factor C, where's my pen? When I factor C, I'm going to be able to factor out a 17. And each of them have at least 3 x's, so 17x cubed. And each of them have at least 1 y of those 2 terms. The 2 terms I'm looking at here and here. So the question is, 17 times what will give me 17x cubed y times what will give me 17x cubed y? It looks like it's just going to be 1 minus, and 17 can go into 34 2 times. And if I take out x cubed, and this is x to 4th, I still have an x left. And if I took out 1y, I still have a y left. So if you distribute this back through, you should get the same thing back as the original. So this is the factored version, and this was our original question. All right, the function machine shown at right. If the input is -2, -2 goes into the function machine. That means I have -2 squared, which is actually going to be +4, which means it's going to be 3 times 4. Change that to a dot. Which means my output is going to be 12. Okay. If the input is 10, that ends up being 3 times 10 squared, which is 100, which means my output is going to be 300, right? It's going to be 3 times 10 squared, and don't forget you do your exponent first, so 10 squared is 100 times 3. If 27, ooh, things get interesting. Look, if 27 is the output, we have to go backwards. If 27 is the output, what got put in to give me 27? Well, I know it has to be 3 times something to give me 27, and that's 3 times 9. But the question is, what squared is 9? Because that's how I got this, which is 3 squared. So my input had to be 3. So if 3 goes in, 27 comes out. Okay? If 147 is the output, what is the input? So you can do it the same way, or, spoiler alert, you could write it as an equation. If 147 is my output, what is my input? We can just solve this equation. So if we divide both sides by 3, we get, help me divide this by 3. 3 can go into 14 4 times 9, 49. And the square root, then I take the square root of both sides. My input would have been 7. Okay? Question C, if the equation for determining the output from a given input is f of x equals 3x squared, what is the equation for determining the input from a given output? So we just need to find, that's another way to ask for the inverse relationship. So we just switch, we make this x is equal to 3y squared, and we solve for y. So we divide both sides by 3. X over 3 equals y squared. Then we take the square root of both sides. So y is equal to the square roots of x over 3. Okay, so this question is just a fancy way of asking us for the inverse operation.